All right, this is day 1 notes with chemical reactions. We're going to try something a little different here. So after today, it's important that you're able to name diatomic elements, write formula equations if you're given the word equation for a chemical reaction. A chemical equation represents a chemical reactions. Reactants will give you or yield products. This symbol right here stands for yield. So we would say reactants yield products. Reactants and products are separated from each other by plus signs. So common forms of chemical reactions are a reactant plus another reactant will give you a third product that's different. Or you could have one reactant that will actually split into two, giving you two products. The third common form is element A or compound A plus compound B will give you two different compounds, C and D. And we'll take a look at these in a little bit more detail as we go through the chapter. Chemical equations can be written as word equations or formula equations. A formula equation can be balanced or unbalanced. Here's a word equation. Iron plus oxygen will yield iron 3 oxide. So this is going to be an A plus B will equal C. This is one compound. The formula equation would look like this. There's iron plus oxygen will yield iron 3 oxide. Now that's the unbalanced form. In order to balance this, we're going to need to make sure that we've got the same number of atoms on one side as we have on the other. So the balanced equation is going to be Fe. We're going to need to have 4 of these. We're going to need to have 3 moles of oxygen, and it will yield 2 moles of our product, iron 3 oxide. If we're counting the atoms, here we've got 4 atoms. Here we have 4 atoms. 2 times 2 is 4. When we're counting our oxygen, here we have 6, and here we have 6. 2 times 3 is 6. This would make this a balanced equation. So that is a balanced equation. There are symbols in chemical equations that you need to be aware of. The symbol, these are going to be the meanings for the different symbols. If you see S in parentheses, that's a solid. An L in parentheses would be a liquid. A G in parentheses would be a gas. AQ, as you already know, means aqueous, which means that the substances are dissolved in water. A double-sided arrow means that it's a reversible reaction. It could go forward or it can go backwards. When you have a triangle over the top or heat written over the top, that means in order for the reaction to occur, you have to add heat. PT is the abbreviation for a catalyst. A catalyst is a substance that speeds up a reaction. Changing word equations into formula equations, you're going to need to use your skills for naming compounds. The first question to ask yourself is the substance an element? If it's a monoatomic element, a normal element on the periodic table, you just have to write the symbol, in this case sodium. The other question to ask is it a diatomic element? These are elements you're going to need to memorize. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine All are diatomic elements. Whenever they're written in a chemical equation, you will need to write them as with a 2 together. These are elements that in nature will not be found by themselves. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Again, you're going to need to memorize these elements. One way to keep the track of them is to remember the term Brinkelhoff. Brinkelhoff will allow you to remember all the different diatomic elements. The next question to ask yourself is the substance an ionic or covalent compound? Let's start with the ionic. Ionic, where you've got a metal plus a nonmetal. Remember, metal and nonmetal gives you an ionic compound. You're going to need to balance the charges in order to get the correct formula. Let's use the example of calcium chloride. When you look on your periodic table, you'll see that calcium will want to lose 2 electrons, so it'll have a positive 2 charge. Chlorine wants to gain 1 electron, so it'll have a negative 1 charge. So the formula for this compound is going to be CaCl2 in order to balance our charges off. In this way, we'll have plus 2 from the calcium, and we'll have 2 of the negative 1s from the 2 calciums, and our charges will be balanced. So again, the formula for calcium chloride will be CaCl2. Now let's take a look at the molecular compounds. Remember, this is a nonmetal that's added to a nonmetal. So these 2 elements will both be nonmetals. Another name for the molecular compounds will be covalent compounds. This is where you're going to use the prefixes for the subscripts. Remember, di is 2, tri, 3, tetra, is 4, penta is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10 for the prefixes. And you're going to use those prefixes to name the compounds. So let's try some examples of word problems into formula equations. All right, so let's try some examples when we're converting into formula equations. So our word equation is sodium chloride plus fluorine will yield sodium fluoride and chlorine. Well, the first thing I need to do is I need to see what the charges are on my compounds. Sodium will have a positive 1 charge. Chlorine will have a negative 1 charge. Fluorine's going to be neutral because it's by itself. Sodium on the product side will have a positive 1 charge. Fluorine has a negative 1 charge. And of course, chlorine is going to be neutral again. So when I'm trying to figure out my chemical formula, I'm going to need to balance these things out. This becomes a 1-to-1 ratio. 1 sodium will balance out 1 chlorine. Fluorine is a diatomic element. Remember Bringelhoff, the F is fluorine, so I need to be sure that I've got 2 as a subscript. This is going to be sodium fluoride. We've got a positive charge on the sodium, a negative charge on the fluorine, so it's a 1-to-1 ratio. And that's going to be plus chlorine, Brinkelhoff. The Cl in Brinkelhoff means chlorine is also a diatomic element, so I'm going to need to put down 2 of them in order to have things correctly done. Let's take a look at the next one, which is aluminum plus sulfur will yield aluminum sulfide. The first thing I need to do is look for where I'll have charges. Aluminum sulfide is a compound, so it will need to be balanced. Aluminum, if you look on your periodic table, you'll see that it has a +3 charge. Sulfide will have a -2 charge. So when I'm putting this together into a symbol equation, aluminum is a monoatomic element, so I just need to put aluminum. Sulfur is also a monoatomic element. For my aluminum sulfide, I've got to balance it off. The aluminum has a +3 charge. Sulfur has a -2 charge. This is where I'm using the crisscross the applesauce. And remember, if I put the subscript down here from my negative ion, and I put the subscript down here from my positive ion, then it will balance out. So I'll have a total of +3 for my cation side. I'll have a total of -6 on my anion side, and these will balance off. So the correct formula will be Al2S3. A helpful hint is to keep all the substances and plus signs in line with each other. So the neater you are in writing these, the less mistakes are going to be made, and you'll be able to keep things straight, and it'll make things a lot easier. Let's go ahead and try another one. All right, let's give this next one a try, where we've got zinc sulfide plus magnesium arsenate will yield zinc arsenate and magnesium sulfide. Normally these would be written in a row, but it's a little cramped for space to keep things big enough to see. I had to kind of crunch things, but you still get the idea. The first thing I need to do is to figure out what ions I'm dealing with so that I can write my compounds. Now look at zinc first. Zinc will have a +2 charge. Sulfide will be sulfur, which will have a -2 charge. Magnesium arsenate, the magnesium will have a +2 charge. The arsenate, each one of them will have a -3 charge. Remember, you can look on your polyatomic ion sheet to see what the charges are. On our product side, zinc will have a +2 charge, and that arsenate, of course, will have a -3 charge. Magnesium +2 and sulfide -2. So you can see this is a double replacement reaction. Basically, our components are kind of switching partners. So the formula, if this is a 1-to-1 ratio, zinc is +2, sulfur is -2, so I'm going to need to have one of each of them. For my next one, magnesium has a +2 charge, arsenate has a -3 charge, so if I crisscross these charges, it'll balance things out. So that'll give me Mg3 ASO4 2. The next one is the zinc arsenate. Zinc has the +2 charge, arsenate again has a -3 charge. I'm going to crisscross these numbers so that I get a balanced compound. So that'll be 3 zinc atoms to 2 arsenate polyatomic ions. Last one is magnesium sulfide with a +2 charge on the magnesium and a -2 charge on the sulfur. So again, this is a 1-to-1 ratio, so the compound's just going to be MgS. That's the end for this, and you can go ahead and get started with the Nearpod, and you're going to practice some with drag and drops, and then you'll go ahead and switch to the actual worksheet itself and finish up the problems.